Object-oriented approach and classification is our new topic. It's topic about design of the system. If you remember, on previous lesson, we talked about life cycle of software, and from these previous lessons, we know that life cycle includes several stages, and one of them is design of architecture, our system, or our products, our software, and object-oriented approach and classification are the parts of design every system. And today we will speak about this concept. When people create a new system, they need some project. This project will present for all members of team of developers what parts um, will be in our system. And for this, people usually use object-oriented programming and object-oriented design of the system. And today, we are speaking about basic ideas and principles of object-oriented programming, object-oriented approach. Now, in this slide, you can see the main ideas, and the first of them is a program as a set of objects with certain properties and behaviors. That means that we have a big system, and this big system will have some parts, and every part will present by object. In your system will be 1, 2, 3, or 10 objects. It's different objects, and every object uh, every object has a special function. And our program is aggregate, is a storage for these objects. These objects interact with each other, and these features need us for organized communication between other parts of program. For example, between user interface and logic of our program, or logic of our program and the part for output data or input data. It's not easy conception, yeah, I know, but today we must explain the basic ideas and understand it. And the basic ideas of this, the first and the second, and the main principles of this approach is abstraction, encapsulation, inheritance, and polymorphism. these principles you can find in another study course, for example, in programming by C++ or system programming, because it's these principles are universal for a big amount of the project. And now I will explain the meaning of these principles. Let's start. Principles of abstraction. Abstraction and this principle means that we must separate of the concept or entity from its instances. For example, around us in our environment, a lot of biological species exist. And if you look on biological species is the concept, the specific representative of a species is the instance. For example, there are cats, dogs, etc. animals. Yeah, and if I am talking you about my cat, yes, he has name. His name is Lubomir. His weight is 8 kilograms. It's about instance. And if I speak with you about cat as a general type of animal, in this case, we speak about concept, not instance. The second example, a building. You know that engineer create some projects for build some building. It's this buildings shops, yeah, factory, plant, house, school, university, etc. And if we speak about building as a project, in this case, we speak about concept. And if we speak about building according to a project, according to this project, yeah, and this building has a specified address, yeah, this building will be the instance of the concept, because concept is a general description of entity. This description includes a description properties or function of entity. And if we speak about instance, we speak not about only properties. We speak about the value of these properties. As like build has specified address, not an address. They have the address. If we will speak about computer, yeah, a computer as concept, we can say that computer has memory, the computer has processor, material boards, etc. component. Yes, but we don't speak about characters of this part of computer. In this case, we speak about concept, about general properties. And if I tell you about my computer, yeah, about computer as a material object with certain characters. And in this case, I speak about instance, not about concept. A concept usually includes some general information about entity, and instance includes information about details, about value of characteristic of the concept. And this principle is one of main principles for next stage for construction our system. After that, after the first principle, we have the second, it's encapsulation. And the main idea of this principle you can see here in this rectangle, a combination of semantically related data and their processing method into a single entity, and this data protection. I have a lot of information about some entity and another entity. But if I use this principle, I must use only information on the data that related with only one concept, only one instance in the next steps. For example, if we will be speaking about results of current and motor control for our students, we can use such data as the name of students and their scores. And it's right decision. And if I will use some information about gender of my students, yeah, about weight, color of eyes, it's not right approach. No, I can't use this characteristic if I need to represent data about the result of current control. What about matters? What about function that I can use for this data? It's set score, editing score, calculation of the final grade for a given student, and calculation um, of quality and success indicators. That's all. I can't use methods that allow me, for example, editing name or surname my student, or editing any information about subject. It's not right. But if I use methods for editing data about scores, it's right approach in this case. Tell me please, do you use these principles in previous discipline, in previous subjects? Maybe in programming on C++?
Sometimes,
Times?
maybe.
maybe from time to time, yes?
Mm-hmm.
Okay, thank you. This principle you can use in different projects. Now I use this principle when uh, I'm explaining some student task for student on first and second course of baccalaureate. Um, I use these principles when I develop my project. It's project about text processing. It's project about mathematical objects such as fractals. Uh, I use these principles when we with our student develop some scientific projects. That mean this principle is universal and we can use it in study, in scientific research, and in another type of project. Sorry, I want to turn off some programs such as Viber. And if we know the first and second principle, yeah, we can go to the next concept. There are concepts of classes and instances of this class. What about the concept of class? We have uh, three elements, three parts of this concept. The first, what about class? What is it? Class is a derived structure type created by a developer or programmer based on existing types. When I will create a new class, I will use several types such as int or integer, float, double, string, char, and another type that I know from previous subjects, previous disciplines, and I will combine this uh, type, the data of this type, for this for create the description a new entity, and these descriptions is type, is structure type, and I will use it in next stage of develop. Uh, every class uh, can contains uh, two parts, its data and functions. Data are the variables. Every variables has own type, yeah, maybe int or double, etc. And the second part of class is function or a several function. From time to time, say this set of function, this function holds methods and data holds attributes. I can use class uh, for description um, some entity. Class usually have attributes and methods, but additional components are possible too. And from time to time, you can find classes that don't have attributes or don't have methods. It's a normal situation too. And what about entity? Yeah, class we use for definite the general properties for describe some entity. If we have classes, we can um, add a new characteristic for them, and for this we can use the principle of inheritance. Inheritance means that definition of new classes based on existing ones by adding new components. New components will be new attributes or new methods, or attributes and methods. It's dependent on type of project, on requirements for new entities. Using this principle, we can create a hierarchy of our classes. We can regulate of inference volumes by the help of modifiers. Modifiers are special words. There are private, public, protected in C++, in other language as C#. We can use not only private, public, protected. We can use additional type of modifiers such as internal or files. These modifiers depend on the language which we use for programming. Let's see for this example of inheritance, because today several cases of inheritance you can find in another project. The first type is a classical hierarchy. We have guest. Maybe it's a guest for website, and our guest can search information and view the result he's searching. But some people need more function for working with site, and this situation allows us to create a new type of users, authorized users. Authorized users will be contain previous elements, these methods, yeah, search and view, and for additional we have new attributes, login and password, and comment. In the class of guest, the attributes login and password is not necessary, because for searching some information, we don't need login and password. But if we want to add some comments, we need login and password. That's why these attributes these attributes are here, and guests don't have login and password. But some people must control the whole site, and they need additional functions such as create an article, delete article, or publish article. Yeah, and we can use next class authors, and authors will contain previous elements such as search, view, login, password, comment, and a new elements create article, delete article, publish article, maybe etc. If this is necessary. As a result, we expand the first class by the second class. We expand the second class by third class authors. And now we can see that it is an hierarchy. The second case of inheritance is this. You can see it in the middle of the slide. We have transport. Transport can write. Okay, it's a logic statement. Okay, the transport has passenger number and baggage weight. It's right. Yes, it's right. It's normal situation. But after that, we need new type of transport. But we want that new type can write to, and that new type of transport has passenger number and baggage weight too. That's the reason why we create new classes. There are plane and train. They are children of transport, and transport is parent class or base class, and plane and train use his elements such as attributes and method. And after that, plane has passenger number, baggage, and has two function or two methods, write and file. And train has previous attributes, passenger number and baggage weight. It can write, and it has additional attribute is buffered car. And the third type of inheritance you can see on right part of this slide. It's about devices, printer, scanner, and MFD. Not all languages support this type of inheritance. C++ supports it, but Java, Sharp don't support this type. They use the another entity they use not classes, they use interfaces. And after that, they can create inherit, inherit, inheritance of third type. If we have this case, we have two parent or two base classes, printer and scanner. After that, we create a new class, MFD. It's a multifunctional device, and this device is a child of printer and scanner, and this device can print, scan, and copy some information. That's all you can find in another project, but not every project use this principle in his book, because this schemes, this combination of classes need only for a big project. Why we need the inheritance? Because this principle give us some advantages of using it. And these advantages you can see in current slide. The first, reuse of previously written code. That mean that your code with inheritance has less quantity of string code than code without inheritance. The second is convenience of additions. Yes, we have some examples of it here. We added new attributes, new methods, or new function in this case or these cases. By the using inheritance, we can reduce the number of errors because in this case we have retesting. We can use design patterns. About design patterns, we will talk on next lessons, and we can use polymorphism. Polymorphism is a case when we have one interface and a lot of different implementations. It's very cool feature, and this feature, this principle, allow us to reduce the amount of parts our system, the amount of string our code. Very good. Maybe you have some question.
No question.
Okay. Then we go to the last principle of object-oriented programming that we can use in our project. It's a principle of polymorphism. That means we can have only one interface and many implementations. And we have interpretation of message to object during execution. What means one interface? interface is an entity that describes some general behavior of our object. For example, behaviors of entity. People can walk using their two legs, but cat, dog can walk too and using four legs. If we have interface animal, we can expand it by two implementation, cat and human. If we use polymorphism, we can say that this principle based on the implicit encasing of object types from the derived facet of the base class. And for realization of this principle, we must using the mechanism of virtual function, because without this mechanism, polymorphism does not work in any language of programming. Virtual function is must have for this principle. When we use polymorphism, we can have two binding, early and late. And the main idea of this type of binding you can see in these slides. Sorry.
Nothing.
Okay. Now we have two parts. The left part describes the main feature of early binding, and the second or right part describe the features of late binding. Let's see on these parts and explain the main details of it. Resume the recording. What about rebinding? This binding you can find in phase of compilation of program. At the compilation stage, all the information is known to allow the selection of the function to be called. Yes, we have a lot of functions and we need to choose only one function. And in this case, we know all list of this function in start. It's usually used when we have a normal function call for calls to overload function and operators. It's very good because time efficiency we have in this case, but it is not flexible method for binding elements. In case with late binding, we can select needed function in execution phase of work with program. It will be later than in early binding, but in this case, the actual selection of the code function is done only during the execution of the program. For implementation of this feature, we need virtual function. It's additional work for us. It's more difficult for realization, but after that, we have flexibility. This flexibility allows you to create a program that reacts to even during its execution without a lot of code that involves different options. In this case, if we need to implement a lot of options, we need implement a lot of code strings. And in this case, we have the smaller quantity of code string than in this. It's very cool. It's very useful. And after that, if we know all principle of object-oriented programming that we can use for create the design of architecture our system, we go to the next concept. It's classification. Yes, we know now that class is type. This type describe developer. This type includes two parts. In this part, we can find attributes. Attributes are variables or constants. And the second part is methods. Methods include function for processing attributes. Yes, but we have a question. How we will separate or how we will select elements that in future became the class. And classification is a definition of classes in this approach. A class is a set of properties. Yeah, attributes and methods are properties of class. We have a lot of properties, and that's why we have a set of properties. An object is recognized by a set of properties. You can use properties static and dynamic. The example of static properties is I'm a human and I have age. It's a static properties. I have eyes. The color of my eyes is gray. It's a static properties. And dynamic properties. Dynamic properties are functions that can I use. It's it's X or it's action that I can do. And properties, dynamic properties can be two kind. There are active and passive properties. If I have active dynamic property, these properties are action performed by the object. For example, I can eat. I can talk, I can see its active properties. And I have some passive properties, some passive dynamic properties. There are action over the object. And for example, teach me is a passive properties. Classification task is divide the word or subject area into classes. Yes, I have a lot of subject around me. I need to classificate it, and for every element of word, I need to create class. And classification help me for solve this task. When we define classes, we use properties. And in this slide, you can see the example of definition of objects or classes by properties. Look, it's very simple object here. It's table. And every table have 4 legs. Yeah. Have one table top. It's a wooden sinks. And another thing are placed on it. Okay, we have some properties. Legs, tabletop, wooden are static properties. Things are placed on it. This statement describes the properties too. It is dynamic properties. It is passive dynamic properties because not table don't do this function, but table are used for this function. The next example, fridge or refrigerator. Yeah, it's a big item. It's a big thing. This thing has 3 walls. Yeah, plus 1 and another side 3. A ceiling, a floor, a door, and it's a wordboard that can hold the code. In this case, we have several properties. If we say about static properties, there are 3 walls, ceiling, wall, door. If we say about dynamic properties, in this case, fridge has an active dynamic properties because this object do this action. And the third example, account. If we talk about account, we know that this object has as well as 2 properties, 2 static properties, login password, and the third properties is static 2. It's list of available operation. And knowledge about properties, about static and dynamic properties allow us to define the object in the word. We have several approaches to classification. It's a heuristic, classical categorization, conceptual clustering, and prototypes. Um, let's see on next slides and explain the details of these approaches. The first, heuristic approach. In this approach, the definition or separation of class is based on the personal experience of the designer. It's a good approach for people who have this experience. And in this approach, possible initial variants of divisions into classes and their improvement, refinement in the next time. The second, classical categorization. Categories are determined in before development, and you can use one of this sequence of categories. The first, subjects, roles, events, interaction. If we want to create project for shop, we can use subject, goods, invoices, roles, sellers, events, movement, receipt of goods, interaction, seller and warehouse worker or storage worker. The second sequence includes people, places, events, concept, and organization. And if you need to create the project for candy factory, we can say the concept. The main things is quality, ingredients, and the final products. Okay, use this conception. We can separate some people and places for describe candy factory. The alternative concept for candy factory is the main thing is maximum profit. It's alternative approach for find elements or find object for our project for candy factory. And the third and the last in this classification is sequence that includes structure, other system, devices, places, organizational units. For example, devices are sensor for plants, people, printers, etc. Other system, polyclinic, hospital, pharmacy. And if we need project for polyclinic, we need to know some devices, its sensor or its bridges, etc. And these elements are candidate for classes in future. Conceptual clustering. What about this approach? In this approach, the conception is a set of goals and methods of achievement. A cluster is a clump of concepts or a set of concepts, and highlighting things that can conceptually affect the system being developed. For example, if I have a system about weather, I need some concept, yeah, and some classes in the future. There will be winds, waterfall, these things, winds and waterfall affect the system being developed. and I use it for describe this system. If I have system about education, I need information about attending classes, about consultation, and if I know about classes consultation, yeah, I can create a timetable for my student notification and etc. Needed element. Prototype. A prototype may be in a early stage of development or for people without experience is a good variant because this method involves a review of analogies as prototypes in order to borrow successful solution. And a third-party project is taken as a basis or core for our development. For example, I need projects. You can see these projects in left side of the table. It will be platformer to direction. It's a game. If I need prototype for this project, I can take to account the existing games, Super Mario, Sonic the Hedgehog, and another project. If I need to create messenger for text and picture messenger, I can use as prototype such software as Telegram, Viber, or WhatsApp. If I need software for video conferences, I can use Zoom, Skype, Microsoft Teams as core for future development. And if I need text editor, I can take to account the features, the function of existing programs such as Notepad, WordPad, Microsoft Word, or Pages from Macintosh operation system, etc. What about methods of primary classification? There are 4 methods. In this slide, you see the first and second and the third and fourth you can see in the next slide. The first is subject predicates. It may be the most easy methods for primary classification. If we use these methods for categorization, we read the technical task or software requirement specification, and all subjects in this task are classes, and predicates are candidates for methods. For clusters, classes are created for a new concept in the technical task. If you can separate new concept, this concept will be a class in future. If we use prototypes and for prototypes, you use subject predicate methods. It means that subjects that are in a technical task or software requirement specification and prototypes are included in the new project. You find requirements in technical task, you find subject in this task. You find subjects in prototype and add it to your project. Structure analysis, the second method of primary classification. The structure analysis is analysis of units and connection between them. For example, if we talk about the record book of our students, in the first stage, the record book is in Dean's office. After that, Dean give the record book to a headmaster of group. Headmaster of group give the record book to student. Student give to teacher, teacher to student. After that, after all courses of after of studying courses, our student give his record book to department, and after that, department give to dean office. And in this example, we can see that we have some structure of university, yeah, dean office, groups of students, teachers, department, etc. And these elements have connection between them, and this method allows us select this connection in the system. The second part of methods, it's the analysis of subject area and analysis of options. In this case, a skeleton model of what we need to be automated is being built. These models and their properties are studied. Based on this, the skeletal model is edited if it's needed. And the last method is analysis of options. It's very expensive method, and this method can be used only in a big project, in a big company with a big budget. Because for implementation of this method, announcement of the competition for the project, successful decision of other participants are added to the winner's project. For implementation this method, you need a lot of variant project. For this, you need a lot of performer for this project, a lot of time, and that's why this method uses only for big project and in big company. And the last method of primary classification is CRC. It's a card that describes a class, responsibility, and collaboration. We will have two types of this card, short and extended version. In short variant, you have only two units, responsibility and collaboration, and in extended variant, we have base class, inherit class, responsibility, and collaboration. You see, base class, inherited class, it's about inheritance as principle of object-oriented programming that you saw in previous slides. An example of CRC application, we have form in our application, user and super user as a child of user class. And I need to describe this element of system. In this case, I can use CRC cards for form. These cards, base class absent, inherit class absent to responsibility, display of the window form input and output information, and collaboration on the user, because you can see one connection between these classes. For users, base class absent, inherit class or child classes is super user. Responsibility, implementation and function available to the basic users, collaboration, super user, and form. Um, because we have two connection in this scheme. And the last class, super user, it have it has a base class user and it hasn't inherited classes. Responsibility, implementation of additional user function, and here we can uh, mm, describe the lists of functions. Collaboration only one because we have only one connection with another classes. And maybe now it's time for resume our lection, and we can say that basic principle of OP are abstraction, encapsulation, inheritance, and polymorphism. We will use these elements, these principles, in the second laboratory work. Classification is definition of classes in object-oriented programming. A class is a set of properties, and an object is recognized by a set of properties. And we have several approaches to classification. There are heuristic, classical categorization, conceptual clustering, prototypes, and for primary classification method, we can use subject predicate as the most easy method, structure analysis, domain analysis, variant analysis as the most expensive method, and CRC cars. This method our student usually use in their laboratory work, in their course work, diploma, etc. That's all. Thank you for your attention. Maybe you have a question.
No.
Okay, thank you.
The laboratory work starts when?
Laboratory work start on 1 o'clock. After break, after 40 minutes.
Do I have to join Zoom for laboratory work?
Yeah, you can use this link for join to laboratory work.
I don't have energy on my phone anymore for today. I
Okay.
know energy here.
I didn't send you. If you have not energy, yes, I did send this case maybe. You can read materials about this laboratory work in Leader.
Okay,
Yeah.
I will. Thank you.
Okay. That's
Okay,
all.
see you next week.
Okay.
Bye-bye.
I wish you good day.
You
Goodbye.
too. Bye-bye.